everyone, this is Tiffany Trader, Managing Editor HPC Wire, and I'm here with Ian Colle, General Manager of Batch and High Performance Computing at Amazon Web Services. Hi, Ian.
Hi, Tiffany. It's great to speak with you again.
Great to speak with you too. Can you give us a little introduction? Like how long have you been at AWS now? It seems like a long time.
Well, strangely enough, I just passed my 5-year anniversary. And it's been quite a ride because I remember starting actually a week before SC in 2017. And that was quite an experience. And here we are a week before SC in 2022.
Yeah, even one thing sort of in our little pre-interview, we were just talking about your official title as like General Manager of Batch and High Performance Computing. I just thought, oh, batch computing, we don't say that as much as we used to say it. And you had an interesting comment about where you see that headed. What were your thoughts on that?
Well, I really see it becoming more interactive. I see the growth between interactive HPC and whether we're calling it composable resources or cloud computing, that those two technologies are really starting to merge because with the enablement of the resources that we allow with being able to compose whatever you need depending upon your HPC workload with the flexibility and the elasticity of the cloud.
And is that is that a design principle that you're working into your offerings at Amazon?
Oh, most certainly. I mean, yeah, I mean the one of the key areas for our customers is the elasticity of our resources and being able to compose the cluster that meets their particular workloads needs. I think we've seen in the past where customers, I mean, when I was a user, we had to compose a cluster that was kind of met the lowest common denominator of the various workloads we were trying to perform on it. And then, we kind of filled it up with other workloads along the way. And you had to kind of make some sacrifices here and there to ensure that you were able to satisfy all those workloads. More and more customers that we talk to are moving away from that monolithic cluster that tries to satisfy everything and where you have to compromise. And they're creating tailored clusters specifically for the workloads. Now, they may not be an 80,000 core cluster, maybe it's a 4,000 core cluster, but it's specifically for that workload. They instantiate it, they run their workloads, and then they shut it down, only paying for the time that they're using the cluster. And then maybe they've got another workload that requires another configuration, maybe more memory, maybe needs some disk, and they create a cluster that has those capacities, and then they execute their workflow, and then they shut that down. And so really with that flexibility of those composable resources that the cloud gives them, it really allows customers to create the infrastructure that's geared specifically to the tasks that they're trying to accomplish, only using it for the period of time that they need to accomplish that work.
Great. Can you give us a kind of encapsulated walkthrough, a high level update of AWS and AI at HPC and AI at AWS? And then we can, dig further into any of those that we want to.
Sure. Wow. Well, in the 5 years I've been here, I mean, it's changed quite a bit. And you've seen us move from where in the early days when I started, we had 25 gig networking. Now we've got, with our accelerated instances, over 400 gigs of networking available. When I started, we had no low latency interconnect. It was all TCP IP. Now we've got our elastic fabric adapter, which is our low latency interconnect that is giving customers sub 15 microseconds end-to-end latency. When I started, we basically had EFS, which is our managed NFS offering for customers to run their HPC workloads on. Now we have Amazon FSx for Lustre, our managed Lustre file system for customers to run their parallel file systems on. When I started, we didn't have any sort of scripts or anything to help them instantiate clusters. We had kind of the notions of an idea of a cloud foundations template that we could use called CFN cluster for customers to instantiate. It was an open source project that we did jointly with Intel, but there wasn't anything really from a managed AWS aspect to help customers get up and running easily on HPC clusters. So we created AWS Parallel Cluster for that. When I started, we just had released AWS Batch, our batch computing scheduler. Now that's iterated for another 5 years. We've added, originally it was built on top of ECS. We've added support for Fargate, which is our managed compute option. And then we just recently announced support for EKS, our Kubernetes offering under there. So we've continued to evolve across that spectrum. So really, it's been exciting to see that journey of where when AWS really started to focus on, hey, we need to meet these high performance computing customers' needs, and just one by one adding these new services, adding these new capabilities, to where now I think really the amount of work that a customer can get done from the most complex workloads, from really high definition weather simulations for numerical weather prediction, whether it's genomics sequencing, most demanding computational fluid dynamics, customers are able to satisfy all those workloads on AWS. And when I walked around at SC 2017, a week after I started, people walked around like, why is AWS here? You guys can't do high performance computing. and now we walk around and we say, well, actually, we can. In fact, here's some of our HPC Wire awards that show how we can satisfy HPC.
Great. I like to see those. So, and I think one instance, and literally an Amazon instance where all these technologies that you're talking about come together is the HPC 6A, which came out earlier this year with the 3rd generation AMD EPYC processors, codename Milan.
Yeah, the AMD Milan, and that has been really exciting to see the way that customers have taken advantage of that. And what they really appreciate is the 65% savings in their price performance compared to previous instances. And customers have really been able to move these massive workloads onto, and weather simulation that I talked about earlier is one of those that's perfect for the Milan chip. And so we've seen lots of weather customers really take advantage of that. And it's been really neat to see that partnership with AMD and just the attraction that customers have for the EPYC line.
One of the apparent pain points I've heard from some customers that use HPC Cloud is getting their cloud clusters to scale. What's the experience been like with the scalability of that instance or other instances that you have?
Oh, we intentionally build out large pools of capacity so our customers can have access to that. As we get signals from customers that that we're going to have additional workloads coming online, then we expand those pools of capacity, and we make those available, not just in like a single area of the world where we try to cram all the HPC customers in there, but we make it geographically diverse where you can get the access to those instances in multiple regions around the globe.
And you have some of the top x86 parts to date, and you also have your ARM processors, Graviton, your in-house designed ARM processors, and then you also have AI. You have instances that target AI. I think you Trainium chips as well. So how do all these things position with each other as far as directing HPC workloads to different targets or directing AI workloads to different targets? And then where does Graviton fit into that? And
yeah, one of the things you'll see, and for some customers, it can actually be a little bit overwhelming at times when you look at the number of choices you have. And that's why we really try to have our professional services or solution architects work closely with an architect team to help them decide what they're going to choose for the right workloads. But we like to think that we give you the best, whether it's our own, as you said, our own generation of ARM processors with the Graviton 3, whether it's the latest AMD, the latest Intel, the latest NVIDIA GPUs. We want to make sure that our customers have access to the latest and greatest technologies from the chip vendor of their choice. We're all about choice and helping them to find the workloads that run appropriately at the right price per performance for them. One of the things that I was honestly a little surprised about has been how rapidly the uptake has been of the ARM ecosystem. While we've seen it very excitedly, I'd say in the academic side of HPC, we've seen some of the ISV vendors be a little slower to migrate some of their codes to support ARM, but much at the driving of ARM themselves to push the vendors that they use to ensure that their codes run on ARM-based systems. We're really seeing an uptick of codes running on ARM. And so it's not just an x86 environment anymore in HPC. It's truly, you can choose the processor that's right for your workloads.
And where are you seeing customers who have big models that they want to train? Where are you seeing them gravitate to?
Yeah, again, it's a choice. NVIDIA is obviously the you know the big kid on the block, and we're the up and comer with Trainium. We like to say that we give customer the best price per performance, and that we can beat them on 40% price per performance with the Trainium instance. With that, NVIDIA has put a lot of time into developing their CUDA ecosystem, and it's going to take us time to ensure that customers can get the best support they can to run their codes as efficiently as possible on our Trainium. And so that's where we see some customers that have migrated quickly to take advantage of that cost savings of the Trainium, and other customers that are taking a more say cautious approach to see how the environment fills itself out, again because NVIDIA has spent so many decades building out that CUDA ecosystem.
And you also have instances with what, A100, H100 coming up? Yeah.
We do. We're gonna, again, I hate to sound like a broken record, but if a chip vendor comes out with a chip that our customers are asking for, we'll get them an instance with it. And we've seen that history over the entirety of EC2. I mean, just in my timeline, we've moved from Broadwell all the way up to Ice Lake, and we'll continue to bring the latest and greatest from Intel, AMD, NVIDIA, and our own.
And you also have a technology called Nitro. I'm not sure if you mentioned that, this hypervisor technology. Tell us a little bit more about what Nitro is and how it fits into your offerings.
Yeah, Nitro is especially important for HPC customers. And what Nitro is really a unique way of doing virtualization. And before Nitro, whenever we did virtualization of an instance, basically you had the virtualization penalty. And so that was where you had to have a subset of the compute environment itself that is off there processing the virtualization environment. And so you're getting a penalty, right? So let's say that you're able to run at maybe 90%, maybe 95% of what the actual system itself could do at a bare metal environment. But now with Nitro, you're closer to 99+% because we've offloaded that virtualization penalty to an entire secondary card. And that Nitro system doesn't just take away that virtualization performance penalty, but it also gives you a whole area of security enforcement and really improves your security profile of your system so that you can be ensured that your data and your compute environment are kept as secure as possible. And that's why we think the Nitro environment is really a game changer once we implemented that.
Is that a key technology across your instances?
It is.
Yep. Kind of circling back to customers, their workloads, what trends are you seeing there in terms of HPC workloads? I seem to be hearing a lot about EDA tapping into the cloud, whereas they didn't so much before. Is that the case? And if so, why would that be on the rise?
It's really interesting, Tiffany. Actually, I see across the board, and I feel like we've reached this tipping point. And honestly, as I kind of recited the litany of all the things we've had to add, there were a number of things we just couldn't do. I mean, customers could try if they're really determined to move their HPC workloads and to shut down their data centers, they could do it. But let's just say that we didn't make it very easy for them. Over the past 5 years, we've taken a lot of that friction away, and we've taken a lot of that heavy lifting away to where now, not only is there kind of this, I'll say, cultural acceptance of, wow, maybe the cloud really is secure, maybe the cloud really is performant, and wow, maybe they actually can meet my price performance targets. So we've added all these functionalities at the same time that there's been a greater range of acceptance within the community about just trying us out. I mean, that's the one thing I always tell the customers is just give us a chance. If you really think that you want to do a bake-off and you think that your on-premises resources are more performant at a better price performance, give us a chance. We have customers that aren't as familiar with our elastic fabric adapter. I mean, it's a newer technology. It hasn't been around as long as InfiniBand, so it doesn't have that name recognition. So where customers say like, hey, where's your InfiniBand for my cluster? Are you sure you can do this? We say, hey, take it for a spin. Let's set up a cluster with EFA. Let us show you the node-to-node interconnect latency. Let us show you not only that, but not just some data from some ping pong tests, but let's actually run the apps that you're performing in operations and see how they perform. So we're actually benchmarking the application performance itself not some synthetic benchmark. And once we do that with customers, they're like, oh, wow, this really is performant. And this is, exciting because this is a new technology and I want to hear more about it.
Mm-hmm.
So for me, that's where it's been really exciting, is to see kind of this crossing the paths where we're becoming more technically capable and customers are becoming more open to the idea of migrating to their workloads to the cloud.
Great. And outside of the main public cloud space, I think we're seeing movement on the private and hybrid cloud side, where system makers are coming out with cloud-like options, names we know like GreenLake and Apex and TrueScale. Thoughts on how that is, which I think a lot of those actually tap into the public clouds. Thoughts on how that is a competitive and or complementary to Amazon and the public cloud space?
Oh, right now, I think they're very complementary technologies. If we see customers that are like an established Dell on-premises customer and they want to use something that kind of integrates with a public cloud vendor, similarly with HPE, if they're an established HPE on-prem customer, they want to have something to extend into the public cloud, I think they can be very complementary.
And then kind of a follow up to that, since I use the term public cloud, I saw a tweet recently, I don't know if you saw it, but someone was a call out tweet for using the term public cloud. I believe the person recommended the term commercial cloud and said, to my mind, I mean, it's kind of an entrenched term. Maybe it's not perfect. No terms are perfect. I mean, public cloud, it's widely used and kind of understood. I don't know. What do you think? Do you have any thoughts on
yeah, I can make it really simple. Let's just talk about the AWS cloud.
All right, there you go. Good answer. Let's see. We saw the first exascale system was brought up earlier this year at Oak Ridge, Tennessee lab there. Is there, would you say that there's a connection between exascale and exascale technologies and what you're doing with the Amazon cloud?
Oh, definitely. I mean, when you see the extreme learning from a computer science perspective that we can get from operating at these extreme scales, I think all of us who work in any sort of computing space, both from just the underlying data center technologies that we'll learn from it, whether it be new ways of power management and cooling, or it be how do we take advantage of scale at that source? How do we work with codes that are scaling out to that size? I think that it's very exciting. And I mean, it's a type of thing that as we continue to grow in the AWS cloud, we'll look at what do our customers ask us for? And will there be a point where customers might ask us for exascale level resources in the AWS cloud?
And you mentioned cooling. If you're able to comment, can you comment on the adoption of liquid cooling at Amazon data centers?
We're always looking at new technologies, and when you increase densities and you increase temperature, you've got to look at new ways of cooling. And so whether that be new technologies for airflow, whether that be new technologies for liquid.
Let's jump from exascale. Where would we go next, but not for quantum? Quantum activities at Amazon. Where does your HPC group sit in relation to the quantum group, and how do you see that relationship?
Oh, we sit right next to each other. I mean, and literally, if we were back in the office, we would be sitting right next to each other. I mean, we're still doing kind of this hybrid remote thing where some of us come into the office now and again, but many of us are still working from home in this hopefully soon to be post-pandemic world. But we are very closely tied to our quantum neighbors. And honestly, we see it as being very complementary technology. We see that quantum, hopefully, should the technology continue to advance and progress, will be part of what are now traditional HPC workflows, that there will be portions of it that we moved off to be quantum accelerated and figured out, and will come back into an HPC workflow. And I think that's really exciting. That's the hope of why we're experimenting with all these various technologies. And it's still early days. We're not sure which of those hardware technologies will really play out. And that's part of why Amazon Bracket has taken the perspective it has of being kind of a common front end for multiple hardware vendors, so that we can give access to various researchers, builders, startups, that can try out those different technologies, and hopefully one of those will work out, and we'll see how we then integrate them into HPC workflows. But at the end of the day, we really see us as being part of one workflow, with part of it being quantum and part of it being traditional HPC.
And you just announced, Amazon Web Services just announced a collaboration with Harvard, part of the Harvard Data Science Initiative. Can you tell us a little bit about what's going on there?
Yeah, I'd love to, Tiffany. It's really exciting. As you and I have talked about in the past, part of the reason that keeps me excited about being part of the HPC community is because of the real, world-changing work that people are doing on our resources. And this is a perfect example of that. So we've partnered with, as you said, AWS has partnered with the Harvard Data Science Initiative in an effort to tackle some of the world's hardest problems. And that's a pretty, big statement there. Well, what can that mean? That can mean, communicable diseases. That can mean climate change, and that can mean the impact of climate change on farming globally. That can mean the impact of climate change on weather patterns and how do people migrate. What does that do for cost of living when you look at economics research? When all those different variables come into aspects, you're looking at some of really, really difficult problems that we need to put some of the smartest minds at Harvard and some of the most capable resources at AWS behind. And so that's why we're excited to announce this initiative with Harvard.
Great. And we're chatting just days before SC. And I believe you're gonna be there, I'm gonna be there. So anything that you're particularly looking forward to and would like to highlight about your SC plans in Dallas?
Yeah, well, I mean, this is going to sound a little hokey, but I was at St. Louis and it was a little bit sad because we're all still wearing masks and there was hardly anybody around. And I know that there's still an initiative for people to wear masks at this one, but at least I'm hoping that we can see more people in public. It's just such a small, tight-knit community. And honestly, we humans are meant to interact not via this medium that you and I are talking through right now, right? We're meant to interact face to face. And one of the biggest things for me is just meeting with my colleagues, meeting with customers, sitting across from them and being able to hear, what do they love? What do they want to see more of? What do they have challenges with? What could we be doing better? And really just hearing their needs, because as we've talked about it at AWS, it's working back from the customers. Those things that I laid out, the improvements that we've made since I started here 5 years ago, every single one of those came from a customer conversation where they said, you know what, I'm trying to do this. This is really hard. It would be great if I could have this instead to make my life easier. And that's why we made those innovations. Again, whether it came from EFA to FSX for Luster, each one of those came from a customer pain point. And so that's what I really enjoy, is talking to customers, hear what they love, hear what we could be doing better. And then that informs how I think about building out the future of our HPC infrastructure.
Yeah, I'm looking forward to it too, and looking forward to seeing you there. Thanks for chatting with me here today, and I'll see you in Dallas.
Okay, see you, Tiffany.